Fossil, for a number of people, has nothing to do with energy. Can mean something, can mean, I don't know, perfume, ammonite, whatever. For me, fossil, of course, relates to energy. So I'm sorry, I wanted to find the Chinese equivalent of this British guy. I didn't manage to do so. But this person is generally, in any country, the most known professor. Whenever he goes on TV and whenever he asks a question, you have a couple million people, and probably in China several 10 million people, that know the answer afterwards. Generally, when this person asks a question, you have four choices. You know them in advance, so it's easy. You call a friend, whatever, choose 50-50, and move to the next step. He never, of course, asks the question the way I'm going to do. Suppose that I take someone at random in this room and ask, according to you, what is energy? In most countries I know, the answer that I will get is energy is a bill. Energy is something I pay. Of course, it's too expensive. It's always too expensive. So it's my electricity or gas bill. Some people might think it's my gasoline bill, although not many. So basically, it's a bill. And if you ask to an executive in a company, then I can assure you that the first thing he or she will answer is it's a bill. You might ask the same question to some people that work in the environment sector. And generally, their first answer is energy means savings. It doesn't mean a bill, it means savings. So energy is something you have to save. Why, how, what is energy, by the way, is not the main question. You have to save it. And then, so I understood that in Chinese it's a tricky one, because it's not the same word. You can ask a poet. And the poet will tell you that energy is something that makes life great. Because when you get up in the morning and that you're packed up with energy, then you're in the mood to do absolutely anything. Well, it happens that the two first answers are wrong, and the last answer is right. Because indeed, energy is by definition what changes the world. Energy is, in physics, as you might remember for some of you, the unit which is used, or the concept which is used to characterize the fact that the world is changing. And to be more precise, energy characterizes the change of state of a system between two stages. The more the system has changed before and after, the more energy has been involved. The more energy you have, the more the world will change. By definition, in physics, it's about as simple as this. I'm now going to illustrate what I've just said with a couple of examples taken from common life. Whenever you change the temperature of a room, for example, you have energy involved, be it to cool it or to heat it. Whenever you have an object that changes its speed, you have energy involved, gasoline for a car, kerosene for a plane, heavy fuel oil for a boat, electricity for a train, whatever. When you have a shape that changes, you have energy involved. Actually, the first shape that you change all the time is that of your limbs. When you change the shape of your arm, you need energy, which is part of the energy which is enclosed in the food you ate. Most of the energy will be used to heat your body, and a little part will be used to think, a very little part, and a little part also will be used to move your limbs. Well, whenever you have in the industry a machine that is changing the shape of anything, it requires energy to operate. You also have energy which is involved when you change a chemical composition. You have energy which is involved when an object that interacts with the field is moving in the given field. And for example, when your body which is interacting with the gravitational field is moving in this field, for example, you get up a staircase, you definitely know that there is energy involved. When you have an atomic composition that changes, you have energy involved, and actually you may notice that all the energies that humanity uses are remote or close derivatives of nuclear energy. Absolutely all the energies we use are derivatives of nuclear energy. And when you interact with radiation, you also have energy involved, and a more common use of this interaction is a microwave oven, for example, or an industrial laser. This is the nice version that may happen in the summer. Again, energy characterizes change. So whenever you count energy, you count change. Whenever you have a change, you have energy. You just cannot avoid changing the world when you use energy. And given this characteristic of energy, something such as clean energy doesn't exist. Because as you may know, being clean is touching nothing. When you use energy, by definition, something changes. And most of the time you realize that clean, in quotes, energy is actually energy which is used in such ridiculous amount that, among other things, the negative effect cannot be very important. An energy which is clean when used in very small amount generally stops to be clean when you use it or when you call on it with huge amounts. Let's talk money. I'm sorry, I'm going to use Western salaries, but I mean, even if you remove 1 0 from what I'm going to explain, you will still understand what I'm saying. If you take something which is close to the, I would say, minimum wage or, minimum wage in Europe, you will pay your kilowatt hour, assuming that you're interested only in physical work, something in between 200 and 2,000 euros, just multiply that by 10 to have yuans globally. Okay? So you will pay your kilowatt hour 2,000 to 20,000 yuans when the machine using oil will be able to provide you the same service for a fraction of a euro or several yuans. So when going from man to machine, it means that you can get the same transformation of the environment for several hundred to several thousand times less money. All that has enabled our industrial civilization lies there. Absolutely all. This has been at the root of the increase of the productivity of work. This has been at the root of the emerging of emerging countries. This has been at the root of the superpower which is called the United States. This has been at the root of your living 70 years instead of 20. This has been at the root of 1 flat per family, 1 car per family among middle classes, etc. This has been at the root of all you know in the modern world. Absolutely all you know. If we hadn't had oil, gas, coal, and more marginally waterfalls, uranium, and so, we would still be living as peasants of the Middle Ages. Now I'm going to say something which is very politically incorrect, and I apologize in advance, but still I'm going to say it. Let's assume you take a slave. As you probably know, a slave is not somebody who has been willing all his life to become a slave. It's not generally something that you wish to do when you're at school, to become a slave. Only for a very small fraction of the population that I won't mention tonight. So, if you're a slave, chances are that somebody will have come to get you against your will. That costs money. Then you must be fed, protected against too much heat, too much cold, disease, etc. Otherwise, the guy that owns you loses his asset. Well, if you pile up all the money which is required to buy a slave and maintain him or her, in life, and you will get to the conclusion that having a mechanical kilowatt hour from a slave is still something which is 10 to 100 times more expensive than using a machine. And the reason why slavery has mostly disappeared from Earth is not because the genetic code of humanity has changed. We have exactly the same genetic code as our ancestors 8 generations ago. It's just because it has become economically without any meaning to use people that might revolt, that have to sleep, that have to eat, and that might escape, when the machine that doesn't do any of this can do the same job for 100 times less money. So energy has freed slaves, basically. As you probably know, physicists have a very annoying habit, that of using laws that you cannot violate. I'm now going to use one law that cannot be violated, even though we would like to, which is the law of conservation, which applies to energy. And that law of conservation says a very simple thing. It's that in a closed system, energy can neither be created nor be destroyed. So when you are looking at a closed system that doesn't communicate with the rest of the world, the amount of energy within the system is constant. And it cannot be anything else. That means something very simple for humanity. It means that humanity can only do one thing when it comes to energy: get some in the environment where it already exists and use it. If we do not have any energy in the environment, we cannot have energy. We cannot create it like Harry Potter with a magic wand. We have to use something that already exists in the environment. Energy that already exists in the environment is called primary energy. It can be oil, gas, coal, uranium, waterfalls, wood, sun rays, wind, etc. These energies are always free, not because I want it, because it's the case. The formation of energy in the environment is free. No one in this room, no one in humanity paid a single cent or a single yuan or a single whatever you want so that energy exists. Okay? Energy existed before humanity. It's there. We only have to go and get it. All natural resources actually are free. Nobody paid a single cent in this room for natural resources to exist. Okay? They are all free. It's very common among ecologists to say that wind and sun are free. This is true. But oil is free, coal is free, and gas is free. All it takes is human work to go and get it, and the rents that you have to pay to the individuals that have the good idea of sitting on it. But that's all you pay. You don't pay the formation of energy. You pay the fact that you access to energy. And that's only human revenues. As all you pay is work to get to the energy, it happens that the more the energy that you can find in the environment is concentrated, easy to extract, easy to carry, easy to store, the cheaper it will be. And that is the reason why fossil fuels, as long as we have plenty, will remain forever cheaper than new renewables. Forever. It's not a matter of political will, industrial lobby, whatever. It's a matter of physics. It's a matter of physics. And actually, it's because of this characteristic that when you look at the history of humanity, we did not go from fossil fuels to renewables. We went from renewables to fossil fuels. The first boats were powered by wind. Sun was used to dry food. And wood was used much before we used oil and coal. So it's precisely because oil and coal and gas are so more convenient than renewables that we went the way renewables first, fossil fuels afterwards. This is a simple calculation to illustrate what I've just said. Just take a cube which has a dimension of 10 meters on each side. Let's assume it's air, so it's wind. Let's assume it blows at 80 kilometers per hour, which is a pretty good wind. I can tell you that when you have this wind and when you're sailing, you'd better look for a harbor and remain still. Well, the energy content of this big cube of air moving at this speed is the same once it's gone through a windmill that the energy content of 3 milliliters of oil. I ask you the question, what do you think is the most convenient to extract from the environment? My cube of air moving fast on the left, or 3 milliliters of oil on the right? Of course, it is 3 milliliters of oil on the right. That's why the technical cost of extracting oil in the Middle East deserts is a fraction of cent per kilowatt hour. A fraction of cent, of euro. Okay? It's ridiculous. Because of this energy, we have been able to put to work our modern slaves, which are machines. A tractor, for example, is the equivalent of 600 pairs of legs, given the power of an average tractor, and it's about the equivalent of the average power of a car. So if you wanted to have people pulling your car so that the car goes at the same speed that it goes with the engine, you would need several hundred people cycling in front of the car. This public works machine is doing the same job that several thousand pairs of arms. If the construction techniques and machines and if the energy was not available today was the same as those that we used when we built pyramids, it would not take a couple months to erect a new tower in Shanghai. It would take a century. What you can see on this graph is that until the beginning of the 20th century, the coal supply per capita rises, then remains constant for about 1 century, and for the last decade or decade and a half has risen again. This is fully the effect of the rise of China. This is totally due to China. Basically, in the rest of the world, the coal consumption per capita is more or less declining. What you can see is that the oil consumption per capita has not replaced the coal consumption, it's gone on top. Then on top of coal and oil, you get gas, hydro, nuclear, biomass, and this tiny little thing is the aggregate of new renewables per capita. So it's the aggregate of wind, photovoltaic, biogas, geothermal, etc. Why is it that coal has risen and then stayed constant? It's because today, and that you know very well in China, coal is the first way to produce electricity in the world, and the electricity production has risen very, very fast during the last half century. Oil is not feeding the same machines. Oil is feeding machines that are used to move, whereas coal is used to feed machines that produce electricity. And we don't move with electricity. We move with oil. Oil is powering 98% of all the boats, cars, trucks, and ships that move around the globe. So oil is by essence the energy of trade, and by essence the energy of movement. Gas has come on top, etc. As you can very clearly see on this graph, until the oil shocks, something that should ring a bell for all those in this room that have white hair like I have. Do you remember oil shocks? Yes, you do. Some other people. The others, you're too young probably, so maybe you've learned the oil shocks in the history books, but otherwise you haven't witnessed the oil shocks. Well, the oil shocks were something that many people in Western countries at least have interpreted as the price of oil goes up, then it goes down again, then we're done with the problem. Actually, we are not done at all with the problems. The oil shock corresponds to a time in history at which the energy supply stopped to grow. The energy supply, per capita stopped to grow mostly. Before the oil shocks, the energy supply per capita was growing at the average rate of 2.5% per year. It means, given the definition of energy, that every year you get 2.5% extra physical flows. That is, tables manufactured, chairs manufactured, cars manufactured, glasses, shirts, buildings, whatever, just name it. It means that with more and more energy, every individual is able to master more machines and therefore produce per individual more goods. That is the very fast rise of production and therefore consumption that has been experienced by the Western world during the before war and after war years. After the oil shocks, the oil supply per capita began to decrease, and therefore the energy supply per capita remained constant. That effect of the last 10 years is actually fully due to China, and if you take the OECD countries, the energy supply per capita has remained constant since the oil shock, and actually has begun to decrease since 2006, and I will come to that later. Still, we have reached today an unprecedented level of energy consumption, and therefore we have acquired for real superpowers that have made us Superman for true. If energy didn't exist, to have the same average standard of living, of course it's very unequal, but to have the same standard of living that we have on Earth at 7 and something billion human beings, we would need some other planet in the solar system with 1,400 billion men on it, cycling all day and sending the energy to us. Okay? That's what it would require to get the same standard of living if we didn't have energy on Earth. Another way to state it is that energy provides to every human being the equivalent of 200 slaves, 24 hours a day, all year round. For nothing. For nothing. That's what energy is. Now, I hope you begin to understand why it's going to be so difficult to bring the population to do without. And now, I hope you begin to understand why the climate talks are not just a formality that we have to go through before we get some magical world. So, our full economic system is basically a gigantic way of transforming natural resources in order to do something else that has more value to our eyes. This is what is our economic system. And transforming resources, as I said, is by definition energy, because transformation is energy. And that energy which allows to transform natural resources is brought for 1 by our muscles and for 200 by machines with energy. And now you begin to understand, if we don't have enough energy, we won't have enough production, even though we have very nice bankers that are ready to lend to everyone, and even though we have plenty of workers. Okay? And the idea, which is commonly spread, that if you increase the population, you will increase the GDP, is false. If you increase the number of machines and the amount of energy, you increase the GDP. If you increase the population with the same amount of machines, you increase the number of unemployed people. It's all you do. Okay? It reverts the equation in a way which is disturbing, I understand. But it's exactly the problem that we are experiencing now in the Western world. Same thing, if you lack resources, you will lack production. Say, if you lack fish to fish, you won't have any GDP for fishing, obviously. With the ratio of 1 to 100 here, you expect the world GDP to move not as the world population, but as the world energy supply. Well, it's exactly what it does. This is the best macroeconomic model in the world that I know. It's a straight line. And it gives you, on the horizontal axis, since 1965, the energy supply in the world, and on the vertical axis, the world GDP in constant dollars. Well, what you can see is you give the energy, you give the GDP. It's very simple. It is extremely simple. And it's extremely logical, given what I've said. This is true in absolute figures, but it's also true when you look at annual variations. On these two curves, the green one is showing you the year-on-year change regarding the energy supply in the world, and the brown curve is going to give you the year-on-year change for the industrial output in the world. No energy, no industry. You probably know this joke by James Galbraith, which was a British economist, who said once, if you ever meet someone who believes that perpetual growth is possible, he's either mad or an economist. If I look at the energy which is making the industrial system possible today, what do I get? Well, I get mostly fossil fuels. Fossil fuels have two characteristics. The first one is that the initial stock that we had when we began the Industrial Revolution has been given to us once and for all, because it takes tens of millions of years to form oil and gas, and it took hundreds of millions of years to form coal. So at the beginning of the very special monopoly that we are playing today, we had a given stock of oil and gas, and we will not get more. So all we can do is deplete the initial stock. Okay, that's an issue. I will come on in 5 minutes because I'm running out of time. I told you. The other thing is that as they are formed of molecules that include carbon, whenever you burn them, you get CO2, and you just cannot avoid that basic chemistry. So fossil fuels are at the root of our purchasing power, because they are at the root of the energy supply of the world today. By the way, at least in the French press, and I understand in a number of other countries, when you look at what is said about energy, or has been said about energy for the last 5 to 10 years, you get plenty of papers on renewable energies. Plenty. What I often say to these journalists is that I am not sure that it's the first thing we should look at. Because when you look at the growth of the energy supply over the last 14 years, what comes on the first step of the podium is coal, and not at all wind or solar. During the last 14 years, coal has risen 35 times faster than solar and 10 times faster than wind. And it happens that coal is an issue if we want to tackle climate change. So we are now, contrary to all speeches that can be made, doing exactly the opposite of what should be done if we want to be serious about climate change. And that's the reason why. It's because we are using more and more coal to generate electricity. As you can see, coal and gas account for 2/3 of the electricity generated in the world today. Oil has a bit. The first renewable generation by far is hydroelectricity. Today we are producing over 22,000 billion kilowatt hours of electricity per year in the world. It was 600 in 1945. 600. Okay, so really reason very fast. Just two little questions. One, how long are we going to get an ever-rising supply from these fossil fuels? Second, what happens once we have put the waste of using fossil fuels, that is CO2, into the atmosphere? These two questions are interconnected. You cannot look at one without looking at the other one. And in between, you have the production of all this, which is the GDP. So now you understand that doing without climate change means doing without fossil fuels, and kind of means doing without GDP. Will we have the choice? The short answer is no. Good news. Short answer is no. I'm going to begin with the upstream part. The upstream part, as I said, deals with the supply of fossil fuels. Fossil fuels have been given to us, and there is an initial stock, an initial endowment in the Earth's crust, which is given to us once and for all. Well, mathematics, simple mathematics, allow to demonstrate that in such a case, one thing you cannot get is an ever-rising supply over time. It's pretty easy to understand, okay? If the stock is given once and for all, you cannot, year after year and forever, have a rising supply. You cannot even, year after year and forever, have a constant supply. We agree? You cannot even have that. All you can have, and it's a math theorem, I can even demonstrate it still, given my old age, tells you that when you start from an initial stock which is given once and for all, if you go back in time far enough, the yearly extraction will be nil, which is easy to check. If you go far enough in the future, the extraction per year will be nil again. And in between, you will have an absolute maximum and a decrease in trend afterwards. That's maths. It's not ideology. It's not my personal wish. It's just maths. So for oil, as for gas, as for coal, as for iron ore, as for copper, as for diamonds, sorry ladies, as for gold, sorry ladies again, as for platinum, as for nickel, as for chromium, as for whatever comes from the earth crust, with an initial endowment, you will have a peak to the annual supply. We are there for oil, almost. Depends what you call oil. We are there for true oil, not there for all liquids. We are already there for gold or silver, I don't remember. We will soon be there for a number of other ores. It will happen anyway, whatever ore and whatever fossil fuel you're looking at. The only good questions are, when at last, how high at most, and what are the consequences? And the last question regarding climate change is, should we desire it, or should we wait for it? But basically, we're sure to have it. Regarding oil, we are nearing the peak. We are nearing the peak, and one way to see it is to look at the growth rate of oil production in the world. That's the growth rate over 1.5 centuries. With very basic means, 1.5 centuries, oil production was growing 50% per year. Then technical means became more sophisticated, and the growth rate went down to 10%. Then, which is surprising, actually, the technical improvement is an answer to the rising difficulties, and it's not the beginning of a new era. It's not going that way. Then we had even more sophisticated and expensive means, and the annual rise went down to 5%. And after the oil shocks, it's almost zero, even though we are tapping shale oil. And actually, shale oil is back to the future. Shale gas has been known in the US for 2 centuries. Okay, so it's back to the future, tapping shale oil and shale gas. And so this is a rough idea of the world oil supply. The blue curve gives you the present year, so you see we're almost at it, depending on what you call. Most people in this case will say, oh my, how much am I going to pay for oil? Well, I will try to explain that it's not the question. The first reason why it's not the question is because you cannot guess the price of oil. The International Energy Agency each year tries to guess the price of oil, and when they guess right, it's by accident. What you can see on this curve, on this red curve, is the real price of oil, year after year, and all the other curves, they represent the guesses made by the International Energy Agency. And you see, during the recent years, they said that it would rise forever, and it fell. So basically, when they guess right, it's by accident. The second reason why is that you have no relation between price and volume regarding oil. On this graph, I've plotted for the last century the price of oil that you get here and the volume of oil consumed or produced, which is the same that you get here. If price and volumes had a true elasticity, the way economists consider it, well, the more oil you have, the lower the price should be, and the reverse way, the less oil you have, the higher the price should be. So all the dots should be along this kind of curve. Basically, it's not what you see. You can have much, much more oil with the same price, the same amount of oil with a price which is wobbling and doing anything. Then again, you can have much more oil with a little change or no change in the price than no more oil with the price doing anything. You have not such a thing as a volume price elasticity regarding oil. You do not have it, by the way, for any mineral ore when you look at long-term figures. Okay? So, something which is at the root of plenty of reasonings of economists is just false. It's very easy to demonstrate. Just look at the past. You have no link either between the price of oil and the world GDP. Same thing, this is the price of oil, this is the world GDP. If there were a correlation, when the price of oil goes down, the GDP should increase, and when the price of oil goes up, the GDP should decrease. Which is absolutely not what you're looking at with these dots. The GDP can increase with oil price decreasing, with oil price increasing, with oil price decreasing, with oil price decreasing. No link. The things that are linked is the world GDP per capita and the volume of oil. What you see on this graph is the year-on-year change. It's a 3-year smooth change, but doesn't mind. The year-on-year change of the oil production and the year-on-year change of the GDP per capita. And you see that since the oil shocks, precisely, the two are strongly coupled, and you see the variation on oil production happening before the variation on GDP per capita. So the best early sign of the variation of the GDP per capita that you have on Earth is the variation of the oil production on Earth the previous year. Looking at this, you could predict the Chinese slowdown. Not very difficult. Not very difficult. Okay. You can also predict the financial crisis in the Western countries. This is the energy supply of the OECD zone since 1965. You can see, probably surprisingly enough for most of you, that the oil supply in OECD countries peaked in 2005. Because in 2005, the world oil supply began to plateau, that is, to remain constant over years. What is still increasing is other things than oil. Natural gas liquids, condensates, but not oil. Oil is constant since 2005. And as we are a growing number of consumers on Earth, then the OECD zone gets less. Because oil is such a big chunk of the energy supply of OECD, the energy supply of the OECD zone altogether peaked in 2006. Actually, it's the result of a trend that has started much longer ago. This is the year-on-year change of the energy supply in the OECD zone, and you see that it was increasing, then less, then less, then less, then went through zero in trend, and now is negative. So the perspective for the energy supply of the OECD zone is that it will go on decreasing, and I doubt we will recover perpetual growth in the OECD zone. I believe even more that we are 1 to 2, maybe 3 years apart from the next financial crisis, severe financial crisis in the OECD zone, precisely for this reason. The rest of the world has a little more time ahead, but basically the trend is the same. And now, in the 30 seconds that I have left, if climate change was to trigger a cooling of the Earth by 5 degrees, I can already give you the death toll, anything between 2 and 5 billion people. All the mid-latitude would become permanently frozen and not suitable for agriculture. And so I can tell you 2 to 5 billion people is probably the correct order of magnitude. I do not have the slightest idea of the possible death toll of a rise of 5 degrees of the average temperature in 1 century, but I can tell you that it's most probably over several hundred million. My personal bet would be something over 1 billion. And my personal bet is over 1 billion because this is going to happen at the same time that the energy supply, which allows us to react to anything, is going to decrease. So if we do not do things fast enough, and if we do not begin to do things with the correct order of magnitude now, not in 2 years, now, we will trigger a situation in which we will have an ever-growing problem with ever-decreasing means to address the problem. And that also most probably means war a little bit everywhere. Because when you look at history, you realize that human populations under stress become selfish and aggressive. That's the way we are built. Okay? It's not because I wish it. It's the way we are built. Basically, what I just told you is, as energy equals GDP, fighting against climate change basically goes with the recession. Name it some other way if you want, but it's going to be very difficult to avoid the two going together. Of course, given the habits that we've taken for 2 centuries, nobody is willing to do it for real unless A, you are already witnessing a recession without having chosen it, which is the case of Europe, and then you're back to the wall, and so phasing out fossil fuel in a deliberate way is your best option. Or B, which might be the case for China, I don't know, the pollution associated with fossil fuels is become so unbearable for the local ruling elite that they want to get rid of it. That's probably also a situation in which some interesting things can happen. If we want to get rid of fossil fuels as fast as possible, we have 5 main sectors in which we should act. In buildings, the main word is efficiency. It means insulating against hot or cold weather. Obviously here, more against hot than against cold weather. In Europe, more against cold than against hot weather, so it depends where you live. In transportation, the easiest thing to do is to downsize all the vehicles we use. Downsize cars, downsize, etc. And favor modal shifts. In the industry, we need plenty of things. Of course, every industrial sector has its own characteristics. So there are very few silver bullets that you can apply to the whole industrial sector taken as just something which is homogeneous. It's not homogeneous. Among other things, in the industry, you have electricity generation, and one of the things which is urgent is removing coal from electricity generation as fast as possible. I personally favor the fact that in the climate talks, all countries should agree on removing coal, that is, not building a single additional coal power plant, and all the, in quotes, emerging or underdeveloped or whatever, call it whatever you want, countries should ask to the developed countries is the way to produce electricity without coal. And it should be the masterpiece of the Green Fund. We shouldn't look at anything else. We should concentrate on that. And in agriculture, the main issue is not to eat too much beef, basically, because beef is producing methane, and it needs a lot of upstream agriculture to be fed. So basically, the heaviest pressure we put on the environment is through eating big animals. And if I may be a little provocative here, I have understood that China is moving from small to big animals, which is not very good news for the world climate. It's better to do the other way around, of course. There are 3 ways to be wise, Confucius said. The first way is think. That's what I've tried to provoke tonight. Time will tell whether I have succeeded or failed. It's, says Confucius, the best way to be wise and to learn. The second best is to imitate those that seem to do proper things. The last one, which is the bitterest, is by experience. I believe that if we try the experience of lacking fossil fuels without having desired it, and climate change without the ways to address it, it will be a very, very bitter experience. At the end, we will realize that it would have been a better idea not to experiment it, but it will be too late, because we won't have a second chance. The time horizon of climate change is in millennia. Okay? Once climate change has begun, you just cannot stop things for millennia, because of the inertia of the ocean and the ice caps. So it's an experiment that we will make once. not twice, just once. And the second thing that Confucius said is probably an answer to the reaction of some of you. Okay? If 2 degrees is too hard to achieve, let's forget 2 degrees. Well, Confucius said, no, if 2 degrees is too hard to achieve, let's really do it. And make it so that things that seem hard are a little bit easier. Thank you.